Ever wondered how a school and a hospital, two seemingly unrelated entities, can share a relationship? Or how the position of a school on an island retains its significance irrespective of the map you're using? Welcome to the intriguing world of topological relationships, a cornerstone concept in geographical information systems, or GIS. Picture this: a school is 2 kilometers from a hospital. Here, the relationship between the two is defined by distance. Now imagine that the school is located on an island. In this scenario, the school and the island are related by an enclosure relationship. These are just 2 examples of the myriad ways in which features can be related to each other in a GIS. But not all relationships are created equal. Geometrical relationships like distance can change with the coordinate system. For instance, measuring the distance between 2 points on a flat map versus an ellipsoidal Earth could yield different results. But topological relationships, on the other hand, are immune to such changes. Whether a school is on an island remains a fact, whether viewed on a flat map or an ellipsoidal Earth. In GIS, there are 2 ways to handle these relationships. One could derive them on the fly when needed, as in the case of calculating the distance between 2 points on demand. Alternatively, one could derive these relationships ahead of time, store them in the database, and retrieve them when required. The latter approach is especially useful for relationships that require time to derive and are relatively static. Topological relationships fit the bill perfectly. They require intensive calculations, and once derived, they remain valid until the next geometric data update. This method essentially trades storage for response time, a common practice in GIS. 3 basic topological relationships are typically stored in a GIS database: connectivity, adjacency, and enclosure. Connectivity describes how lines connect to each other to form a network. Adjacency describes whether 2 areas are next to each other. And enclosure describes whether 2 areas are nested within each other. To derive these topological relationships, lines are restricted from crossing each other. These lines, which observe this restriction and are topologically related, are often referred to as arcs, not to be mistaken with circular arcs. These arcs terminate at nodes, and each arc joins 2 nodes. These arcs then form the outlines of polygons. Nodes, arcs, and polygons create a hierarchy of topological elements, forming the foundation of topological structures. In a nutshell, topological relationships are a crucial part of GIS, enabling us to understand and interpret the world around us in unique ways. They are not affected by the coordinate system and give us insights into how different features are connected, adjacent, or enclosed. These relationships are typically pre-derived and stored, making them readily available for analysis and interpretation. The world of GIS is truly a fascinating one, where a school and an island can share a meaningful relationship, and every line, node, and polygon tells a story.